Lazy evaluation. Laziness is never appreciated, but here laziness through lazy evaluation brings tremendous time saving and efficiency for Spark by avoiding unnecessary operations. Well, we'll understand all of these details through an example. But for now, can you look at the superhero on the screen? He's sleeping right now. Do you want to guess his name? His name is Spark. Yes, he's sleeping. But this is a very alert sleep, remember. And do not make a mistake of thinking he doesn't know what is happening around him. He's observing each and everything happening around him during the sleep. Just the difference is that being a superhero, he's not doing that action right now. And he has conveyed this clearly to us. He's saying, I'm not lazy. I know what to do. I'll wake up when real action is required. Remember this word action, because this is a core concept which helps us understand lazy evaluation. And this action is what the superhero is waiting for. So let's understand what action means. Spark has a concept of transformation and action. These are two kinds of operations. Well, let's take a look at transformation first. Suppose we have data of people with their name, age, and the city they reside in. And this data is sorted in ascending order by age. If I ask you a question, just filter this data and return back to me the rows with age greater than equal to 40. Well, these are these rows. That's simple. I ask you this question and you return back this data. So what has happened over here is there was this data and this operation returned back a transformed version of that data. Such an operation in Spark is called transformation, where the input is data and the output is transformed data. What is action? On this same data, if I ask you a different question now, okay, give me the count of rows in this data. The count is 10. Or if I ask you another question, say, save this data as text file. Then you give me the output of text file. Such an operation is called action. I've listed a few transformations and actions examples on the screen, but these are just few out of all of the transformations and actions offered by Spark. And if you need the full list, I suggest you can easily refer Spark's official documentation to get the full list. So, this was the action which our superhero Spark has been waiting for. We now know action, but we still don't know how it is a secret sauce of Spark. And precisely, how lazy evaluation works. Well, let's take a look at it through an example of flights data. We have this flights data, which has 3 columns. The origin country from where the flight took off, destination country where the flight landed, and the number of flights between these two, origin and destination. The information we want from this data is the top 5 destination countries along with the number of flights. Well, I'm now going to share the SQL logic to find this answer, but if you would like to, you can surely pause this video and think about the SQL query to find the top 5 destination countries. Well, through SQL, all you need to do is just group this data on destination country name, do a sum of count column, sort this data in descending order, and do a limit of 5, and that should fetch you the top 5 destination countries. Let's see how we can do this in Spark. So we can achieve this using Spark SQL. Spark SQL is one of the components of Spark's ecosystem which provides us functions to run SQL queries in a distributed way on very large volume of data. So we first create a data frame on this flights data. This flights data is in the form of a CSV file for us, as you see on the screen. So all we need to do is we need to run a read function which reads this CSV data. Then we execute the same SQL logic which I just explained to you, which is we just do a sum on the count column, do a group by on the destination country name, we sort it in descending order, and do a limit of 5. Now these are transformations. Let's see when we run this in Spark SQL, how is it judged and formulated by our Spark's engine superhero. So when we run a read transformation, it generates a data frame from the CSV file. At this point of time, our superhero is sleeping because it's a transformation. It doesn't do anything. It's just looking at the transformations you are giving to it, and it is forming a lineage graph. When you run a group by and do the sum, similarly, it doesn't do anything. It is still sleeping and taking that alert sleep. Remember, when you sort it in descending order, it is still sleeping. And when you do a limit of 5 to find those top 5 countries, it is still sleeping and observing the whole lineage. And it is waiting for that action. And here show is that particular action. So as soon as it sees show, it runs this collect to return back the result. And this is the alarming point for this superhero. As soon as it sees that show action, it gets into action and it wakes up. And at this point, it wakes up and does the optimization to return back the results to you in the most efficient way. Well, this explains to us how lazy evaluation internally works. But we still have an open question we are thinking about. How is it even making Spark efficient? I mean, what efficiency benefit is it providing? Let me tell you, the benefits are huge. Let's understand it. So, if we have a data set of different people, we have their name, age, city they reside in, their email, date of birth, and this data set has 1 billion rows. In Indian numbering system, it's 100 crore rows. Imagine the size of this data. And the date of birth column is in format YYMMDD. And we are using Spark to convert this into DDMMYY format. Remember, this is just a transformation and not an action. And at this point, our Spark engine superhero is still sleeping and waiting for an action. As soon as we tell Spark, okay, display me 10 rows with converted date format, this is an action for it. And the alarm rings. And our superhero wakes up and thinks about the most optimized way to return the required result. And as part of this optimization process, in this case it will think, okay, well, you're asking me to return back to you 10 rows with the date format conversion. You haven't asked me, okay, give me the 10 rows of the youngest people in my data or the oldest people. Because for that, I need to sort all of the 1 billion date of birth column values to find the youngest or oldest people. But you're not asking that. So why do I even need to scan all the 1 billion rows? So it does this efficiency calculation and just picks up 10 rows, converts them to DDMMYY format and returns back the result to us. And this exactly is the efficiency we achieved through lazy evaluation, where it avoided the expensive scan of 1 billion rows of data. When we call a transformation in Spark, Spark engine doesn't just immediately start performing that operation. It is smart enough to just record whatever you are requesting it. It keeps a lineage of all the operations you are asking it to do, but it doesn't start just working on it. It is smart enough to take that judgment call. So, for example, if you run a sc.txt file, it doesn't start just keep loading that data without even looking at what you actually need. So it doesn't even load the data until it is necessary, until it has looked at that action you want to perform. So Spark uses lazy evaluation to reduce the number of passes, the number of visits it makes to your data. Well, how does it do this? So if in your Spark code, you're running different operations in different portions or segments of your code on one particular data set, what it will do, it will group all of them together to avoid again and again revisiting that data, which leads to costly read operations. So this is the kind of smartness and efficiency it provides us.